Why is the angle of incidence equal to the angle of reflection? Let's look at the principle of least action. The law of reflection states that the angle of incidence is equal to the angle of reflection. But why is this true? To empirically test why this is true, we're going to observe the reflective behavior of light through the principle of least action. Now let's investigate the law of reflection using a numerical simulation. So here I'll click reflection, and that'll bring me to this simulation. I'll click and drag to create a point, and click and drag again to create the endpoint for my light ray. Let me zoom out, and you'll see the angle of incidence, reflection, time, and action all being printed out. I have my angle of incidence in blue, an angle of reflection in green, and my action in orange. Okay, great. So what you're about to see is my angle of incidence and reflection converge upon each other. And you can see as they approach one another, this green and blue graph get closer and closer together. And my action is becoming smaller and smaller. In fact, the horizontal axis for this graph is the incidence to reflection angle ratio. So as that ratio approaches 1, and indeed you can see it has approached 1 right here, my action has become minimized. In other words, my action is minimized when my incidence and reflection angles are equal. As such, that is why the law of reflection must be true, because the action is minimized when my angle of incidence is equal to the angle of reflection, aka when their ratio is 1, the action is minimized. Now some questions to guide further discussion might be, why do other trajectories fail? Why can't you go straight for the metal slab and then go to the second point? How can we prove this geometrically, that the law of reflection must work? Think about these questions, and that's it for proving the law of reflection using a numerical simulation of the principle of least action.